Hello. So today we're gonna try to solve this problem. Let me quickly. I solved that problem maybe sometime in the past, like 2 years ago. But let me revisit it again, and I'll try to solve it again. Let me quickly read the problem. Okay, let's check this case. So we have we have 5, 10, minus 5, so means that 5 and 10 flying to the right and minus 5 flying to the left, and means that 5 and 10 never gonna meet, and 10 and minus 5 they gonna meet. And because the one that found the state of the asteroids at all collisions. Okay, so in this case, the smaller one will explode, the minus 5 will explode, and I'm gonna have 5 and 10. Okay, and that's gonna be a final state. Okay, in this we have two asteroids colliding into each other, that's why we have a 0, like empty output, and we'll have here, let's say, minus 5. So we have minus 5 colliding into 2, and then it stays minus 5, and then it's colliding into 10, and okay, so yeah, so the idea, I have this idea that basically every time let me describe this idea I have right now. So we have this input, make it bigger, how we can make it bigger, large, and bigger, large. Okay. So we have this input, and my idea is actually to have the pointer, and then I'll put the asteroids to the stack, into the stack, and then let's say we have initially we have like something at the end. We have like minus 10, we don't consider it. We have like, say we have minus 10, minus 20, and then 6, and those asteroids gonna fly to the left, and this one gonna fly to the right. So we'll ignore the ones that on top that's currently pointing, and we have like empty stack. But if we have like positive asteroids, like we're gonna add that to the stack. So let's say we have this one 0, 7, okay, 0. No, I don't want to remove it seems like this one is connected to the okay, we have 10, 2, and minus 5, and then we have a pointer pointing on 10. We update our stack gonna have 10, inside. Then we're gonna move our pointer to 2, and then our stack becomes, let's say, stack becomes, we add, it's not minus, so we add it on top. We have 2, then 10, and then we see the -5, and we do the following. We do the check who's gonna survive. In this case, -5 gonna survive, and 2 gonna remove. So we pop the 2 out of stack. We have 10, 10 there, 10, and then -5 incoming. So like, say we have, initially we have 2 10 in the stack, and we have -5 incoming. Incoming here, and then -5 incoming, and then it's gonna remove 2, and then we have 10, just 10. I have just 10 there, and we have still -5 incoming, and then we're gonna check who's gonna win here, and then it means that 10 gonna stay, -5 gonna collide. So in the result we have like just 10, and then we run out of pointers. So we moved pointer to the right, and then there is nothing to the right. So the idea is this is using stacks and having this while loop, check if we need still, if we still have the candidates for the asteroids, and kind of we go from left to right, and with those who are colliding, we are checking one by one for those that are colliding, if they're gonna survive. That's it. So like the time complexity, we're gonna have pointer pointing to the every element in the array, so it's gonna be O of n, and then for the every element in the array, we either gonna kind of go to stack, and the maximum we can do is like remove all elements in the stack, but we can do that actually once, so it's still gonna be time gonna be O of n, and space gonna be O of n 2, because we'll have a stack, and the maximum number of elements in the stack gonna be n. So let me quickly code this solution. So I'm gonna have this stack integer equals new stack, and then I'm gonna have for int I equals 0, I minus less than st, its length, and then I plus plus, and then while stack is empty, and so we have two states. If the current asteroid value I is less than 0, then we need to do this colliding stuff. And we'll have also this array list result. So like if the asteroid gonna fly through all this that's moving to the right and smash them, I need to save that in the output array. So if stack is empty and not is empty, and if the asteroid, if the stack peak less than, if it's greater than I just exit, if it's less less or equal, okay, let's have there are a couple states there. So if the asteroids I and like stack peak, if they are equal, so if they are equal, I need just to, so it's gonna destroy this asteroid, it's gonna destroy the one that's on stack. So I need stack pop and then break this while loop. Else if stack peak, if the asteroid on the stack is greater than asteroids, so it's mass abs also here. If it's greater than the current that the asteroid there that's flying, let's make it bigger. If it's greater, that it means that we need to just break. If it's else, so if the current stack peak, if, and let's say we have boolean to add. Oh, okay. We have if, so it's gonna be actually stack peak less than mass abs asteroids. Then we need to do the following. We need to do stack pop, then we need to check if stack is empty. We need to just to add this asteroid result add asteroids I. It's gonna be the last iteration, so I don't need to do the break. In case it's if it's last iteration, then I need to do the break. If it's not the last one iteration, we're gonna continue cycling through this stack and checking if it's gonna smash or not, or stop anywhere in the branch. And in the end, what we need to do is to just go through the one by one from the our array, and then we can from the stack. So do that while stack not is empty. We do integer value is equal stack pop, and we need actually to add that. So we're gonna have this asteroids flying, so we need to So the problem is how to save the order. If we just gonna add it to the end in the order of stack pop, it's gonna be reversed. So I need to somehow account for this and add it to the kind of Oh, I know what I'll do. I'll do this. I'll have this result equals new integer, and then I'll have already out. So I'll have output. Output equals let's say flying left. Call left length plus stack size, and we'll do the following for int I equals 0, I mean less than flying left length I plus plus, and then here flying length output I equals flying length left I, and then for int I equals, then while stack not empty, I'll do this integer pointer equals output length -1, and then we're gonna pop, and then we're gonna put the output our pointer, then minus minus equals stack pop, and then return the output, something like that. Let me trace a few examples. Let me trace a simple example we have right now here. So if I'll trace it, input, you have input this, we create flying left array, it's empty, so it's empty. Flying left is empty initially. Empty. We go through the asteroids, and initial asteroid is 10. Okay, we have, I missed the branch actually. If the asteroid is greater than 0, we just add that stack push, and here stack push asteroids I. So current asteroid is 10, so we have stack equals 10. Okay, next one. Asteroid is 2, so we have 0, 1. Stack is gonna be equal to and 10. I had gonna be at index 0. Flying left. Okay, flying left. Okay, on the second index, I'll have -5. So this is we're gonna branch into here. While stock not empty, we'll do the following. If stack peak, so the double stack is gonna be 10, is equal asteroid, so not this one. If stack peak is greater, no, it 2 against so you have this one input, it's and the asteroid equals -5. So the stack peak is less than the asteroid value, absolute value, and it means that we go to this branch, we do stack pop. So we pop this one value, so our stack becomes like just 10. We check if it's empty. No, it's not empty. We go to this while loop, and we check it's not empty. We check peak, stack peak actually greater than asteroids, so we just break. Flying left is empty, stack is equal 10, and the output, we're gonna have the output equals flying left empty plus stack size equals 1, so the total flying output length is 1. We're gonna not enter this one loop, we're gonna go to this one, and pointer's output length -1, so it's output length is gonna be like pointer is equal 0. Stack is not empty. We put the we pop the value from a stack, it's gonna be 10 here, and we put it in the array and decrement the pointer. Because stack becomes empty, we don't go to second iteration. When we output the we return the output. Let me write down public static void test1, and then we'll have solution. Int input equals then 2 -5, and then int expected output equals actually 10, and we do this solution equals new solution and then int output equals solution dot asteroid collision, and then input, and then boolean plus equals arrays equal, then in output, then expected output, and then we can print a result. Okay, so and we're gonna call this test1. Let's quickly run and check. 44. Probably length here. No, the same. Okay, so it's size, and this is probably also size. 45. I guess it's called collections. Collection? No. What about collections? No. Past. This is okay. Typo. Okay, that's one passed. Let's quickly check if it's passing here in the Leetcode tester. In the Leetcode tester, if it's gonna actually pass. Let's check. Not really. So in this case we have -1 and 1 colliding with each other, and -2 and 2 colliding with each other. Ah, so like -2 flying to the... Okay, so like I guess I did the wrong one, but still, like if even according to my logic, okay, expected. So based on my logic, if the asteroid is negative, if stack is empty, stack is empty. Okay, so even it's not colliding. So first of all, this one flying to the left. Yeah, okay. So it's kind of edge case. Even so I need somehow to why don't I just do this with a simple trick? I'll just, if I gonna break, so if they gonna break each other, I'm gonna just put the asteroid equals asteroids 0, I equals just 0, and here the same as here the same asteroids I is equal 0, and then I'll do this simple trick. If there if asteroid in the end, if their asteroids I is not equal 0, I'll just add it 0. I just add it to our flying left array. Okay. Okay, so since I failed this interview, I was solving this problem for 30 minutes, and one edge case, I didn't account it for that edge case. When we have like empty, when we have like asteroids in the beginning flying to the left, and there's no asteroids to stop them, and in this case I will just drop them, while I should save it in the I should have saved it in the flying left array. Yeah, interesting problem. What's here? Here they have just a pointer and moving them between the asteroids array. Yeah, and we basically check if it nullifies the asteroid. So we have this current asteroid and destroyed true, while it's not destroyed and index greater than 0, and asteroids in the under their index is greater than 0, and current asteroid is less than 0. We do what if it's greater than 0. Okay, so it's just simple if they kind of nullify each other. Okay, and if they nullify each other, if current asteroid and then the previous asteroid, like, okay, so we basically check it's gonna go through. Okay, so we're gonna move around this asteroid in our asteroid array, and we're gonna kind of check if it removes if it's gonna smash the asteroids, and if it's gonna smash it, how we gonna reflect it. Okay, we're gonna just, if it smashes, we just increase the index. If it smashes, we're gonna save it in the end. Otherwise, we will just start at the end. Okay, I'll if the actual asteroids that are before it, that are moving to the right, if they are bigger, then we're gonna just stop decrementing the index. If they are smaller, it means that we'll start decrementing the index and we'll override them in the end. And yeah, so this is kind of in place modification. And after we did this in place modification, we just copy the head of this asteroids array that we used for a thin trim. And yeah, that's fun. That's interesting solution. Everything's in place. It's like off, and time, and off one space. Yeah, that's a pretty interesting one. Let's check out the time and space for this one right now if we do that. It's good on time, but in memory still not that good. I wonder why. We don't use memory here. The delta is pretty small here. And let's check what they do. Stack. System GC, okay, you're funny. And we do system GC, trying to trick Leetcode. I wonder why Leetcode doesn't do this system GC check and just remove that one, because it really screws up the statistics there. Stack again, but some fancy function programming in the end. This doesn't look like functional programming at all. This one in the end, cherry on top. Okay, let's check what's here. Again, stack, and then this one, conversions, and then okay, the same. Yeah, the funniest one, the most interesting one is this one. Not this one, but the one that I tried actually. Sometimes this here. Yeah, this one is just, they override it and they have answer, but they still override the asteroids. Yeah, that one is similar to the previous one. This one is stack. This one is again stack. This one is again stack. Okay, everything is. This one is also stack and array answer. Okay, guess that's it. I can wrap up. So as I said, I didn't manage to solve it within like 20 minutes. Also had one edge case. I didn't notice that, so it's fail.